Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be talking about like terms. We're talking about like terms. We're talking about terms that have the same variable. 5x and 3x are the same because they both have x's attached to them. 5 times x and 3 times x are like terms. Versus unlike terms which have different variables. 6y and 7z, variables are different, so they're unlike. This also applies if we'd had 5x squared and 3x. Those are also unlike terms. The variables are different if the exponent is different. So in this case, let's take a look at 5x plus 3x. We have 5x, we get 3 more x's. We can just add the numbers as we normally would. 5 plus 3 is 8. We have 8x. The second one, we have 10y minus 6y. I always think of these, or find it helpful sometimes to put a name in for the y. If I have 10 yo-yos, I lose 6 yo-yos. How many yo-yos do I have? Well, 10 minus 6 is 4. I have 4 yo-yos. I have 4y. So 10y minus 6y gives me 4y. If I had 1a, there's no 1 written just because it's unneeded if there's only a 1. But I have 1a plus 1a. A plus a, I have 1 apple plus I get another apple, and I now have 2 a's, 2 apples. I had 1b, and I lost a b. I'm at 0. I have nothing. It works with variables the same as it would for anything else. 1 minus 1 is 0. In this case, we have some like terms and some unlike terms. We have negative 3x plus 4y minus 2x. Even though they're kind of separated by the positive 4y or plus 4y, we can still combine or collect these like terms of negative 3x and negative 2x plus the 4y. So I'm actually going to do the x's first. When in doubt, we're going to do these in alphabetical order. So negative 3x is my first term, and it goes with the negative 2x. Now I know it looks like subtract 2x, but really we think of it as saying plus in brackets negative 2x. So if I have negative 3x and I get 2 more negative x's, I'm at negative 5x. And the other animal that I have, the other creature, the other term is the 4y. So I can add that in plus 4y. And they're in alphabetical order, x before y. Right. So in this case, I have 7k plus 4c minus 3c plus 2k. So let's look at the different terms we have. We have 7k, or positive 7k. It's going to go with the other k, the positive 2k. And we have a c, we have a positive 4c. Notice I'm taking the sign before it. And we have a negative 3c. So the c is actually our first alphabetical, so let's do that first. So 4c subtract 3c, 4 minus 3 is 1. And if I just have a 1, I'm just going to write the variable. So c, or 1c. I have 7k, or positive 7k. I get 2 more k's. I end up with positive 9k. So we can end up with a very long expression. If it's all addition and subtraction between each term, then we can still collect the like terms. If there's some multiplication and division in here, then we wouldn't be able to collect it all, but because it's all addition and subtraction, we can. So let's look for the different animals, the different creatures. Let's look for all the A creatures, all the A terms first. So I have 6 A's, 6 antelopes, and I lose 7 antelopes. Not quite sure how that works. I have 5B, and I lose 4 B's. And I also have 2 C's, 2 cats, and I get 8 more cats. I also have something else out here on the end, just a number with no term. It's actually a different type of animal. It's going to all be by itself at the end. So let's look at my A's first, alphabetical order. So I have 6 antelopes, I think I said. I lose 7 antelopes. I'm at negative 1, or negative A. I don't need to write the 1. So I've taken care of my 6's, my A's. So let's look at the next cage and put the next animal in its own cage. I have 5 B's. I lose 4 B's. I'm at plus B, or plus 1B. So I've taken care of those, put them in the same cage. I've got 2 C's, I get 8 more C's, I'm at 10C. And I've got this number on the end, which is an unlike term, so it just gets its own cage, it gets its own place. We just put it on the end plus 6. So in this case, I put my A's first, even though it was negative. I notice it's A, B, C. My variables in alphabetical order. My positive 6, which has no variable, is on the end. If I had 2x squared plus x plus 3x squared plus 2x, I actually have 2 different types of animals here, even though they're different x's. I could even throw on a 5x and make it really big to the power of 3 cubed. I've actually got 3 different types of animals here. I've got the x. They're going to go in their own cage. We've got an x squared. It's a different type of animal. It's going to go in its own cage, just like in the zoo. And we've got the x cubed, which is going to go in its own cage as well. So we're going to try to combine everything that's the same. So let's take a look. First of all, we've got a 5x cubed. I'm going to start with the highest variable first, 5x cubed. And then I've got 3x cubed. I get 2 more x cubed. So I'm at, squared. 2x squared plus 3x squared is 5x squared. And then I've just got an x by itself, so I'm going to add x in here. So we can't actually combine these. If we thought about it as 5 times x times x times x plus 5 times x times x plus x. Anytime we have multiplication or division, we can't combine like terms. We can only collect the ones that are like this. Way to think about this, even though they're all the same, they're the same type of species, maybe they're all dogs. We got the little dog, you got the little teacup poodle here, you got a slightly larger dog, and you got a really big dog. You're not going to put them in the same cage, in the same kennel. You're going to put them in different places, just like we do with this. Thanks for watching. Be sure to check the class website for the assignments, additional notes, and examples.